Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to continue on a new topic. On the same topic, but a new same chapter, new topic, right? Confidence interval for different of two means, right? So previously we are already looked into hypothesis for one sample t-test, right? So we want to see the difference of the mean, right? So today, let's say we have two group of population, and then we want to know which group have higher mean or not equal, right? So there are two conditions that we're going to look in this topic. Firstly, when population variance for both group are equal. Another one is population variance for both group are unequal. So there are two conditions to be looked into. So first one is condition when the population variance for both group are equal. Another one is population for both group are not equal. So we're going to compare two groups in this topic, right? So when the population variance are equal, so the standard confidence interval will be mean x bar 1 minus x bar 2, means the sample mean for group 1 minus sample mean for group 2. Basically, we want to find the difference of two mean for sample mean. And then we're going to use t distribution, right? T distribution, alpha divided by 2, right, with v degree of freedom, right? And then since the population variance for both group are equal, then we're going to pull the standard deviation, right? For standard error ni, ini semua ni kita panggil standard error kan. All of this we call as a standard error. And remember the punya basic formula, right? Mean plus minus our t distribution or calculated statistics with v degree of freedom multiply with standard error. So this is the standard confidence interval, right? So when the population variance are equal for both group, we need to do a pooled standard deviation. We need to calculate pooled standard deviation. So pooled standard deviation are calculated based on this formula: n1 minus 1 multiply with S1 squared, which is this is the variance for group number 1. So then we do for group number 2, n2 minus 1. This one we call as a degree of freedom, right? Degree of freedom. And this is for variance for group number 2. And this is the degree of freedom for both group, right? So n1 plus n2 minus 2. So remember here, if you look at the degree of the total degree of freedom here, n1 plus n2 minus 2. So kita tengok dekat sini, this one tengok betul-betul lah. This one t alpha divided by 2 with degree of freedom. So degree of freedom here is not n minus 1 because now we have two group. So we need to do a pool degree of freedom, which is n1 plus n2 minus 2. So this is the degree of freedom for t alpha divided by 2 v, right? So now for unequal variance, right, when the population variance for both group are unequal, so we're going to use this formula. So this formula same as previous: x1 minus x bar 1 minus x bar 2 plus minus t alpha divided by 2, right? And since the standard deviation, the variance are not equal, so we can do straight away punya calculation. Variance for group number 1 divided by n1 plus variance for group number 2 divided by n2. So this is our standard error. Since the variance are not equal, right? So since the variance for both group are not equal, so the degree of freedom is slightly different lah, right? So as degree of freedom, the formula for degree of freedom is this one, right? So S1 square divided by n. So variance for group number 2 divided by number of observation for group number 2, and then u squared divide by, and benda yang sama you copy back dekat bawah dekat denominator ni, and divide by n1 minus 1. So yang mana belum buka switch on webcam, tolong switch on webcam dulu. So you make sure you understand when to use this formula and when to use this formula, right? To use the first formula, right? First formula, the condition should be equal variance for both group. For second formula, the variance for both group should be unequal, right? Very simple. So now, to test the equality of variance for both group. So to test the equality of variance for both group, we're going to use Levin's test. Levin's test as shown in Spss output, right? So the hypothesis for equality of variance using a Levin's test, null hypothesis will be variance are equal. Alternative hypothesis, the variance are not equal. So this is a standard hypothesis statement for Levin's test. By looking at this one, right? So if our p-value is less than alpha, right? No matter what amount of alpha you are using, let's say alpha is 0.05. So if p-value is less than alpha, we're going to reject null hypothesis. If p-value is more than alpha, we're going to accept null hypothesis. Right? So if the p-value is less than alpha, we're going to reject null hypothesis, and we're going to conclude that variance are not equal. When the p-value is more than 0.05 or more than alpha, we're going to accept null hypothesis, and we're going to conclude that variance are equal for both group lah. Right? This is our decision rule, right? So this is our hypothesis statement for Levin's test, equality of variance test, right? Hope you understand this one. Very simple, straightforward. So let's look at example number 12. So example number 12 basically dia dah bagi jawapan kan. So kita tengok dulu, right? So example number 12, the following data represent the length of time in days to recover for patient randomly treated with one of two medication to clear up with severe bladder infection. So we have first group and the second group, right? This is the group number 1, and this is group number 2, which is group number 1 consider medication number 1, group number 2 taking medication number 2. And the sample observation in group number 1, we have 14, and x bar is equal to 17, and sample standard deviation, sample variance equal to 1.5. Remember, this is a sample variance, and this is also same as medication 1. Medication 2, number of sample is 16, mean is equal to 19, and variance for medication 2 is 1.8. So find 99% confidence interval. So 99% confidence interval, alpha will be 0.01. Right? How we get this one? 100 minus 99. Right? So you will get 1 lah. So 1%. So this is in terms of percentage. Kalau you convert to probability value, we divide by 100. So you get 0.01. So remember, alpha always presented by a probability form lah. It should be in probability form. So alpha is a type 1 error again. Probability of type 1 error. So find 99% confidence interval for difference in the mean recovery times. Different in mean recovery time for two medication. Assume that normal population with equal variance. So when we have equality of variance, so variance are equal, x bar 1 minus x bar 2 plus minus t alpha divided by 2 with degree of freedom. So when variance are equal, so v, our degree of freedom, will be n1 plus n2 minus 2. Right. Remember, tengok balik muka surat 109. Right. So degree of freedom is n1 plus n2 minus 2. So this is the degree of freedom. And the standard error will be pool standard deviation multiplied with 1 divided by n1 plus 1 divided by n2. So this is the formula that we're going to use for variance, population variance are equal for both groups. So now we input the value into the formula. x1 minus x2 is equal to negative 2. The degree of freedom, n1 plus n2 divided by minus 2, it should be 28. And pool standard deviation, this is, you need to carefully input the value and carefully calculate the value. So pool standard deviation should be 1.2887. Right. So then you input the value into the formula. Right. So now we know that T alpha divided by 2 with degree of freedom. Sama dengan kat sini kita dapat T 0.005 with degree of freedom is 28. Right. It should be equal to 1.2887. So how to get this? So kita tengok dalam statistical table lah. So tengok dalam table, statistical table number, I think table number 7, right? Muka surat 16. So 0.005, degree of freedom is 28. So 2.763. Sekejap. Tengok ni, dia letak 29 kan? Oh no. Dia betul lah, ni I salah tengok. This is 2.763. Where is it? 763. Right. So assuming this is a correct calculation lah. So this one berapa? Cuba tengok betul-betul. Ni semua buku ni pun salah kira kan. So tengok betul-betul. So 14 plus 16 minus 2 should be 28 lah. So this one salah. This one dia kata 29. This is should be 28 and this is wrong lah. Right? Okay. So can you reconfirm this one? Is it correct? Can you reconfirm? 1.2887 lah. Alright, good. So betul lah. So just plug in the value into the formula. So this one, x1 minus x2. So 14 minus 16 should be negative 2. So negative 2 here, negative 2 plus minus 2.763 multiply with 1.2887 and multiply with 1 over 14 plus 1 over 16. So then you do a calculation and you will get the value of confidence interval lah, right? And then you can conclude that this one you need to check back lah, what is the value here. So we are 99% confidence that the mean recovery times, the difference in mean recovery times is between negative 3.3 to negative 0.7. So you will check back balik dia punya calculation whether it's correct or not, right? But this is basically the way how we're going to calculate the confidence interval. Now let's look at example number 13, right? So a study was conducted by the Department of Zoology to estimate the difference in amounts of chemical measured in two different stations of river. So two different stations of river. So the chemical was measured in milligram per liter. 15 samples were collected from station 1, 12 samples from station number 2. Right, and this is the description lah. So find 95% confidence interval for difference in true average chemical content, assuming that the observation came from a normal population with different variance. So now we have a different variance, means that the variance are not equal. The population variance are not equal, right? So this is the statistic value they give to us. So remember, when the population variance are not equal, right? So x bar 1 minus x bar 2. This is what we want to find the difference of the mean, kan? Difference in true average. So plus minus T alpha divided by 2 with V degree of freedom, and the standard error will be S1 squared divided by N1 plus S2 squared divided by N2. Is it? Kita tengok balik dia punya formula. Is it correct or not? Yes. Right? With square root ambil set dekat situ. Right, now the only difference here, right, with the previous example, right, the population variance are not equal. So when the population variance are not equal, so then we need to find degree of freedom. So we need to calculate our degree of freedom. So degree of freedom S1 squared divided by N1 plus S2 squared divided by N2 divided by S1 squared divided by N1. This one plus S2 squared divided by N2, and this one N1 minus 1, N2 minus 1. Right, ada square tak kat luar? Kita tengok balik. I think this one should be squared, and this one should also squared. Kita tengok balik formula. Yeah. So this is the formula for degree of freedom. So now we can straight away, we need to find degree of freedom dulu lah. Senang kan? Boleh cari degree of freedom dan kita boleh plug in the value masuk dalam formula. So this one should be 3.07 divided by 15 plus 0.8 divided by 12, and then this one squared divided by sama ya 3.07 15, and then this one squared plus 0.8 divided by 12 squared, everything divided by, this is 15 minus 1, this is 12 minus 1, right? The total should be equal to 16.31, right? You need to confirm this one, right? So then you just plug in the value into the formula. So 15 minus 12 plus minus, this is a 95% confidence interval, so this one should be T 0.025 with 16.31 degree of freedom, right? And then multiply with the standard error. So standard error will be 3.07 divided by 15 plus 0.8 divided by 12. So remember dekat sini tengok what happened here, tengok balik formula. Dia kata kat sini formula, the value of S1 square ni, the value of S1 square ni, right, dekat sini adalah representing the variance kan, variance S1 square, S1 square. So apa yang kita buat kat bawah ni, ini adalah value of standard deviation, right, S1 saja kan. So we need to square dekat sini lah, everything square, right. So baru dia nampak lah. So this one should be macam ni lah, betul. This one is correct. So kita tengok dekat sini, this one should be S1 squared, S2 squared, and then taking a set lah. Right. So now we want to see what is this value, 0.0 T alpha 0.025 with degree of freedom 16.31. So by looking at this one, 0.025, 0.025, right? So 0.025, 16 will be somewhere here lah, right? 16.2, 16.3, and this one 17. And this is 70.0 kan, 2.11. So they should be 2.12 lah. So paling dekat dengan 16 adalah 2.120, right? So you just plug in the value and do a calculation. So you will get this confidence interval. Right. So let's look at the confidence interval for different between two means. Right. So this is the Spss output. Right. I forgot kita ada I promise to you I nak buat satu Spss bengkel. So maybe after we complete this chapter, right, kita buat dalam kelas sajalah, right? Right, kita tunggu habis chapter ni lah, chapter 4. And kita sebelum masuk chapter number 5, kita tengok introduction sikit berkenaan dengan Spss. Right? Okay, so this is the Spss output. So basically we're going to get two table output. First one is group statistics. Another one is independent sample. test. Right? This is the same presentation as previous, kan? If you still remember. So, if you tengok one by one, so this is a variable, right? Test 1 is your variable. And then we have two group here, group A and group B. And this is a sample size for group A, and this is a sample size for group B. And this is the mean for group A, and this is the mean for group B. Standard deviation for group A, standard deviation for group B. The standard error for mean for group A. So how to get the standard error, right? So mean divide standard deviation divided by square root of n, right? So you will get the standard error for group A. So standard error for group B, standard deviation for group B divided by square root of n, right? So standard error of the mean, right? So standard error of the sample mean. Standard error of sample mean means that the standard deviation, so dekat sini standard error of difference, right? Standard error of difference between two group. Standard deviation for the difference divided by square root of n. Square root of n means that the total observation lah. Alright. Okay. So the mean difference dekat sini, right? Mean difference dekat sini adalah the 32, the mean for group A minus mean for group B lah, right? The mean difference. So now tengok dekat sini, dia ada satu part dekat sini name as Levin's test. So dia satu line dekat sini je. Dia ada pemisah dekat sini satu line, right? So this is the Levin's test. Ini yang kita nak tengok tadi tu. So Levin's test dia bagi kat kita F value and significant value. Significant means that the P value lah. So dalam independent sample test ni kita ada dua part, right? So this is the first part, this is the second part. Second part starting from here to here, and this is the first part, right? So first part is about Levin's test for equality of variance. So we have F value and significant. This is a P value lah. So dekat sini kita ada dua row. First row is equal variance assumed. The second row is equal variance not assumed. So macam mana nak baca this one? Ini dibaca dekat sini. So untuk yang ni, untuk the first one, Levin's test, kita hanya baca this one satu saja. So the hypothesis for Levin's test, remember tadi, variance are equal and H null, H alternative, variance are not equal, right? So since the P value is more than 0.05, which is our alpha, so we are rejecting alternative hypothesis. So we are reject this one, this is a reject, and this is accept. Since the P value is more than 0.05, we are accepting null hypothesis. Since we are accepting null hypothesis, so kita akan assume variance are equal. So when we assume variance are equal, we are going to read on first row and we ignore the second row, right? If the population the P value is less than 0.05, is less than 0.05, right? So we're going to reject null hypothesis. We accept alternative hypothesis. So variance are not equal. So we're going to focus on the second row. We ignore the first row, right? Boleh? So dekat sini we have the t value, right? So we have a different color. This is the t value, and this is the degree of freedom for variance equal. This is the degree of freedom when the variance not equal. So we can calculate, we can prove it by our formula tadi. So this is a p value, right? For two tail, this is the mean difference, standard error, and that's 95% interval of the difference. So kita dah tengok this one kan, 95% interval, confidence interval for the difference. This is the formula. Benda yang sama kan, kita dah buat tadi. T alpha divided by 2 n minus 1, and then standard error of the mean of the difference. Okay, so the p value here, when the hypothesis is assume that there are no different on both group, right? This is the first hypothesis statement. Null hypothesis, when the mean for both group are no different, right? So if the p value is more than 0.05, so we're going to accept null hypothesis. We can conclude that mean of both group are no different, right? So when the p value is less than 0.05, we're going to accept alternative hypothesis, and we can see that the mean of the both group are different. Right? It's not equal to 0 means different lah. So kalau kita manipulate dekat sini sikit, right, kita bawa let's say null hypothesis asal dia mu1 minus mu2 equal to 0. It's supposed to be mu1 equal to mu0 kalau kita bawa this one ke sana. Right? So means that we can say that mu1 is equal to mu0, mu2. So sama juga dengan alternative hypothesis. Mu1 is minus mu2 is not equal to 0. So kita bawa ke sana, mu1 is not equal to mu2. Okay? So, any questions so far? Any questions so far? Soalan? So if you don't have any question, then we move to the next topic, which is hypothesis testing for difference between two population mean. Right? Benda yang sama lah. Alright. Sebab tadi kita dah tengok dah, right? How to calculate the statistic. So this is how we construct hypothesis testing lah. Right? Benda yang sama. Right? So if we have two population of sample, we are interested in comparing mean between two independent group, right? So let's say we have two-tail test. If we have two-tail test, mu1 minus mu2 equal to 0. This is also equal to mu1 is equal to mu0, mu2, right? If this is a standard null hypothesis for all tests, right? So when we are measuring two-tail tests, if we are looking into the difference between two groups, right? So we're going to put not inequality, right? Inequality before 0, right? Mu1 minus mu2 not equal to 0. So this is a two-tail test, right? So for one-tail test, same concept as previous. If you have less than or more than, so it's going to be a one-tail test. So if it is less than, so it should be on left hand side. So if it more than, should be on the right hand side, right? If we have non-equality, so it should be both sides lah. Right? The concept of rejection are still equal. Right? The concept of rejection sama saja macam sebelum ni lah. Kejap message masuk tak berhenti. Okay. So sama saja untuk Z test and T test. So now let's look at two-sided. So this is another topic. Unknown but equal variance. Unknown mean tapi kita ada equal variance. We have unknown mean but equal variance. So another condition is known mean so unknown mean but not equal variance. Kita ada dua lah. So kalau kita tengok sebelum ni kita dah tengok yang sebelum ni, this one, we know mean, the population mean, but we don't know the population variance, right? So now, so dia kata kat sini, tukar color, right? Two-sided hypothesis on two means can be written generally. So mu1 minus mu2 equal to D. So this is what we call as, we don't know the value of population mean. When we don't know the population mean, so we just write equal to D, right? Where is the difference between two means, right? So this is general hypothesis lah yang kita writing, right? So benda yang sama juga kalau kita manipulate kan, kalau if D is equal to 0, right? If D is equal to 0, right? So mu1 is equal to mu2. Mu1 is not equal to mu2, provided when mean equal to D is equal to 0. So the two sample pool standard deviation, right, or two sample pool t test, right, mean x1 bar, x bar 1 minus x bar 2 minus D. This one is supposed to be, and by right kita belajar sebelum ni, mu1 minus mu2, right? So we replace it to equal to D, right? So and then bawah ni sama saja. This is a standard error when the population variance are equal. Right, we are using pool standard deviation. Benda yang sama. Right, and the the degree of freedom n1 plus n2 minus 2. Let's look at the second one. Unknown but unequal variance. Right, there is a situation where the analysts are not able to assume variance for equality of variance for both groups. If the population are normal, then the t statistic is x bar 1 minus x bar 2 minus D, and kita letak standard error kat bawah lah. So standard error for unequal groups, so S1 divided by N1 plus S2 divided by N2. And the degree of freedom, of course, is slightly different. We need to calculate the standard degree of freedom. Normally, when we do a calculated standard degree of freedom, so selalunya kita tak akan dapat the whole number lah. Kita akan dapat the decimal or fraction number. Right? But the concept are still same. Still same as previous. Benda yang sama. Right? We just change the value of calculated t statistic and the degree of freedom. So now let's look at example number 14. An experiment was performed to compare abrasive wear to different lamination material. 12 pieces of material were tested by exposing each piece to a machine measuring wear. So 10 piece of material 2, right, was similar tested. So dia ada 10 lah. This is 12, right? So in each case, the depth of wear was observed. Sample 1, response benda yang sama lah. Can we conclude at 0.05 level of significance that the abrasive wear material 1 assess that material 2 is more than 2 unit? So dia dah kata dekat sini, material 1 lebih daripada material 2 sebanyak 2 unit. Right? So null hypothesis will be the same. mu1 minus mu2 equal to, so since dia dah bagi satu benchmark kan, more than 2 unit, so equal to 2 unit. Maksudnya tak ada perubahan lah, sama saja. Right? Alternative hypothesis will be mu1 minus mu2 more than, lebih sikit, exceed material 2 by 2 units. So this is our hypothesis statement. So our alpha is equal to 0.05. So the dimension 0.05 level of significance. Our test statistic will be T. So dia kata kat sini last kali dia kata, kita tak tengok kan. Assume that the population to be normal with equal variance. So when we have equal variance, so x bar 1 minus x bar 2 minus mu1 minus mu2. So this is a standard formula, right? Standard formula. So we're going to replace this one with 2 until later on. So divide by S1 squared divided by N1 plus S2 squared divided by N2, taking a set for everything. Wait. This is a formula for unequal variance, kan? But our condition is equal variance. So we need to do a post-standard deviation lah. So this one should be S pool multiplied with N1 plus N2. So then we need to calculate post-standard deviation. Post-standard deviation will be, the formula is this one, right? So N1 plus minus N1 minus 1 square root, variance of group number 1 plus N2 minus 1 variant for group number 2 divided by N1 plus N2 minus 1. This one should be minus 2, right? This is the degree of freedom, right? N1 plus N2 minus 2. So you just plug in the value here, should be equal to 4.4777, right? And then T distribution, T statistic will be, you just plug in the value dalam tu. So 85 minus 81 minus, this is equal to 2, right? Mu1 minus mu2 equal to 2. So it should be equal to 2. Right, and then this one divided by 4.4777. Right. So multiply with 1 divided by 12 plus 1 divided by 10. So this one should be equal to 1.0432, right? And we know that the degree of freedom is this one lah, 12 plus 10 minus 2. So next is our critical region. So our critical region, this one should be always T distribution juga kan. T distribution is a normal distribution, right? It came from the standard normal distribution. This is from negative infinity to infinity. So since we have a one-sided test, kita tengok dekat sini dia kata alternative hypothesis mu1 minus mu2 is more than 2, right? So it should be on the right hand side. On the right hand side. So this is going to be alpha 0.05. And this one should be T 0.05 with degree of freedom is equal to, how much do our degree of freedom? 12 plus 10 minus 2 should be equal to 20. Right? So T alpha 0.05, degree of freedom 20. So 0.05, 20 is 1.725. So this one should be 1.725. So our decision since our T statistic is falls in acceptance area, right? So then we're going to accept null hypothesis, right? So remember, this is a rejection area and this is acceptance area. So since we accept null hypothesis, so our decision is, conclusion is, we have no enough evidence to conclude that the difference of material 1 and material 2 more than 2, right? So we have not enough evidence to conclude that abrasive wear of material 1 and material 2, so ataupun the difference of material 1 and material 2 more than 2. Right? So now let's look at example number 15. Researcher want to investigate the carpet if carpet room contain carpet room 1, right, dia kata kat sini carpet room 1 contain more bacteria than uncarpet room number 2. So colonies of bacteria cubic foot form in petri dish from 8 carpet room and 8 uncarpet room. So we have equal group, kan? Based on the result of SPSS output table number 2, answer the following question. So this is the result, eh? Basically kita tengok table ni dengan table yang sebelum ni yang kita tengok ni, basically benda yang sama, kan? Dia sama saja, cuma dia ubah the layout is different oriented lah. So this is based on white format and this is based on long format. Mana tadi? This is a long format. Long format ke bawah, wide format tadi yang tu ke tepi tu lah. Still benda yang sama. So we have a Levin's test. We have F and significant, which is this is a p-value, and we have equal variance assume, equal variance not assume. So this is a t statistic, degree of freedom, p-value, mean different, standard error different, right? This is standard error, 95% confidence interval of the difference. So state the hypothesis for the test. So dia kata dekat sini, you want to investigate if carpet room contain more bacteria than uncarpet room. So the hypothesis will be mu1 minus mu2 equal to 0. Right? Mu1 minus mu2, right, more than 0. So kalau this one mungkin susah sikit nak faham, right? You can do like this, yang suggestion yang dia bagi ni, benda yang sama, right? Tapi at the end, I want it to convert to this one. Boleh? So based on the result, what is the assumption of variance? What is the assumption of variance? Ayat ni mengelirukan, tapi tak apa. As long as we understand, they want to know what is the result. What we can conclude from the test of Levin's test of equality of variance, right? So you just state the null hypothesis for equality of variance. Variance are equal. Null alternative hypothesis, variance are not equal. So alpha 0.05, p-value is equal to 0.541, right? Kita tengok p-value dekat sini, 0.541. So since p-value is more than 0.05, since the p-value is more than 0.05, null hypothesis is rejected. Null hypothesis is accepted. Null hypothesis is accepted, then we can conclude that the variance for both group are equal. Right? So this is a step lah. Kita kena buat. So apa yang step yang kita ada kat sini? The first one is state the null alternative as hypothesis statement. State the level of significance, the p-value, the decision, and conclusion. Boleh? Right. So now, the next question is, using the p-value in the output, do the data provide sufficient evidence to indicate the carpet room contain more bacteria than uncarpet room? So now, since we are using the p-value, right? So dekat sini, kita boleh tengok since the group are equal, kita akan tengok the first group, the value for the first, for unequal, equality of variance assume, the first column lah, I think, yes. The first column, kita akan tengok the first column. And we ignore the second column. Right? Benda yang sama. So the p-value here will be 0.376, right? So, since kita tengok dekat sini, this is for two-tailed test, right? For two-tailed test, right? So the formula of p-value, we need originally we multiply with 2, right? So to get one-tailed test, we need to divide by 2, right? So p-value equal to 0.376. So this is, since our problem here is for one tail test, right? But the p-value dekat sini dia bagi is two tail test, right? So we are dividing by 2. So we will get 0.376 divided by 2. So it should be 0.188. So since the p-value is still more than alpha, which is 0.05, right? So we're going to reject alternative hypothesis and we are accepting null hypothesis. Null hypothesis is accepted. So when the null hypothesis is accepted, so we can say that, we can conclude that there is no enough evidence to reject null hypothesis and conclude that the bacteria for carpet room and uncarpet room are same. Alright. So next is state 95% confidence interval of the difference in mean colonies of bacteria, right, between carpet and carpet room lah. So the mean difference, the confidence interval of different, kita boleh ambil dekat sini lah. So this is the confidence interval of the different, negative 1.8. This is a lower confidence interval and upper confidence interval. Negative 1.85 and 4.60. Right, so we can conclude that we are 95% confidence that the mean difference, right, of colonies bacteria between carpet and uncarpet room is between negative 1.85 and 4.60. Any questions so far? Right, let's continue on example number 16. So the Faculty of Hotel Management and Tourism is interested in comparing class assessment score of two different group students taught by two different lecturers. So table 4 and table 5 represent Spss output, right? So table 4 tells us class assessment marks out of 40 marks, right? Group A and group B, right? So group A we have 245 students. Group B we have 274 students, and this is the mean error of the standard error of the mean. And this is table number 5 is tell us about Levin's test, and the p-value of the Levin's test is 0.000, which is significant, which is we're going to reject null hypothesis, And then this part is our t statistic, right? So based on 95% confidence interval of the difference, right? 95% of confidence interval of the difference in the class assessment mark, what can you conclude? So first thing, you need to look into relevance test, right? Always look into the relevance test to decide which row you want to use, whether the first row or the second row, right? So since the p-value is less than 0.05, right, which is 0.00 something, so we're going to reject null hypothesis and accepting alternative hypothesis. So accepting null alternative hypothesis means that we are concluding equality of variance, not the variance for both groups are not equal. The variance for both groups are not equal, so we're going to read based on the second row. We're going to read the result based on the second row, right? So based on the confidence interval, kita tengok of the difference. So we have negative 2.961 until negative 1.437. So we have 95% confidence interval, right, of the difference of confidence interval, the difference of the mean assessment mark is between negative 2.961 and negative 1.437, right? So based on the confidence interval of the difference, so since the confidence interval of the difference is not include 0 in the interval, so we can say that there is no difference. So there is a difference. There is a difference between group A and group B, right? So since the confidence interval dekat sini, nampak ni dalam ni, tak ada 0 dalam ni kan. So this is from 2.961 until negative 1.437. So 0 dekat sini kan, and then start 1 kan. So 0 tak ada dalam interval ni. So means that the p-value should be less than 0.05 to indicate that there is a difference between group A and group B. So if the faculty wants to test whether the class assessment mark of the group taught by lecturer B is higher than group taught by lecturer A, so state the appropriate null hypothesis and alternative hypothesis. So null hypothesis, mu1 minus mu2 equal to 0. Right? Ataupun kita boleh letak macam ni lah. This one is more clearer lah. Mu1 equal to mu2. Right? Alternative hypothesis will be mu1 is less than mu2. Right? So kalau nak senang faham kan, tak payah letak mu1, mu2. Right? Kita menggunakan apa yang dia bagi, simbol yang dia bagi. So alternate null hypothesis mu A equal to mu B. Right? So we know that group A, mean of group A is same as mean of group B. Alternative hypothesis mu A is less than mu B. So means dia kata dekat sini assessment mark for B is higher than group A. So mu A less than mu B. So this is easy to understand. Okay. So test the hypothesis in B using 1% level of significance. So null hypothesis is this one, right? This is a null hypothesis, right? So alpha is 0.01, right? So test statistic, right? So test statistic dekat sini, since this is a one sample, one sample test, one tail test. This is one tail test, right? So one tail test, the result that we have here is, this is for two tail test, right? So dia tak cakap dekat sini menggunakan p-value, right? So we are assuming we're going to use t distribution. T is equal to negative 5.699. So 669. 669. Our degree of freedom is, so then we need to put a critical value. Critical value, since this is on the left hand side, so should be the area that we want to cover is on the left hand side. So this is from left hand side. So from negative infinity to infinity. So this is our 0.01, our alpha, right? And remember, this is acceptance region and this is rejection region, right? So our critical value will be somewhere here lah, T 0.01 with degree of freedom. So what is our degree of freedom? So since the equality of variance not assumed, right, there are no variance equal, so the degree of freedom is 435.5. 435.5. So look at the statistical table. 0.01 degree of freedom infinity is 2.236. It should be negative 2.236, is it? 326. So dekat sini we can conclude that decision, since our T statistic falls in acceptance area, right? C falls under rejection area and negative 5 kan? So rejection area, null hypothesis is rejected. So we're going to accept alternative hypothesis. So conclusion would be, we can conclude that the assessment mark for group A is group B is higher than group A. Ataupun bila kita boleh kata, we have enough evidence to conclude that the class assessment mark for group taught by lecturer B is higher than group taught by lecturer A. Okay? So that's how we answer question number 16. So question number 17, kita ada banyak example 17, 19. So ada 19 je lagi. Right, example number 17. transport plays a very important role in tourism industry. So I think macam dah pernah tengok example ni. Okay. Two companies accommodating the rail service to same destination, which are company A and company B. Right. The study was conducted to inquiry the average price of season tickets spent by the customer by choosing the rail service. 65 customer from each train. So kita ada 65 customer for company A and company B. Right. The result of the price season ticket spent by customer is shown in table 4 and 5 below. Right, so 65 customer from each train who either using train from company A, company B are selected random. Right, so same presentation as previous, right? Cuma layout je berbeza. Based on the result, what is the assumption of both variance? So we can look at the Levin's test, right? The p-value for Levin's test is the p-value is less than 0.05. So kita kata sini 0.05 kan dia nak. Dia tak cakap kan 0.05. So we are assuming the 0.05. So since the p-value is less than 0.05, right? Because sini the p-value for Levin's test is less than 0.05. So we're going to reject null hypothesis. Null hypothesis is rejected. So what is the hypothesis? Kita kena specify lah. Null hypothesis is variance are equal. Alternative hypothesis ataupun you boleh letak macam ni lah, the symbol kita guna. Since kita guna symbol semua lah. Variance 1 is equal to variance 2. Variance 1 is not equal to variance 2. Right. So null hypothesis is rejected. So we can conclude that variance for both group are not equal. Right. So prove that the standard error of the different means is 0.5667. Right. So standard error of the difference. So how to get standard error of the difference? So standard error of the difference we got the standard error of the difference based on the standard deviation of the difference divided by square root of mean, square root of n kan. So kita tengok dekat sini. Mana dia dapat 7.5 tu? Okay, to prove that the value standard error of the difference is 0.5667, right? So before we do this, let's look at the previous example, right? On this one, right? Okay. So now let's look at this one. Let me clear all the notation here, right? So we can see without any annotation, right? So now let's look at the standard error of the difference, right? Standard error of the difference, which is 2.75271, right? So remember in previous previous formula, we already look at this one, right? So we know that this is the standard error, right? This is a standard error. This is also a standard error, right? So standard error is, let's say for unequal variance, S1 squared plus divided by N1 plus S2 squared divided by N2. This one taking a set for everything. This one for equal variance. Pool standard deviation, 1 divided by N1 plus 1 divided by N2 and taking a square root. Right. So since, let's look at this one, equal variance assume, right, and equal variance not assume, the value of standard error of the mean are same, right? So we know that either formula can do, right? So standard error will be square root of S1 squared divided by N1 plus S2 squared divided by N2. So this is based on the formula we got from the confidence interval, right? This one I think quite easy to understand and quite easy to calculate. So alright, so let me use another color. Right, so this one should be square root of the standard deviation for group A is 6.08927 squared divided by N1 is equal to 15 plus, let me make it over here skip. Alright, so this one should be 8.75112 and then squared divided by 15. So when we do a calculation here, right, let me take out the calculator. Right. So let's say we put this one should be 6.08927 squared divided by 15 and plus with the variance 8.75112 squared divided by 15. So you will get 2.752. 2.75271, does it? 71. So this is the same value as SPSS gives to us. Right. So now let's look at this question that we are discussing now. Yeah, this question. So the same method, right? If you bring out the same method, so square root of S1 squared divided by N1 plus S2 squared divided by N2. But if we look into wait, alright, for this one, if you want to use this formula, right, it seems that we don't have the value of standard deviation, right? So what we have is a standard error of the mean. So this standard error of the mean is representing S1 squared divided by N1, right? And this one represents square root of S2 squared divided by N2, right? So we cannot simply add these two value together to get this one. Of course, it's not equal, right? So remember, let me emphasize this one. Square root of S1 squared divided by N1 plus square root of S2 squared divided by N2 is not equal to square root of S1 squared divided by N1 plus square root S2 squared divided by N2. So this is mathematically different, right? So what else? What is the option left to us, right? By looking at the t-test for equality of mean, so we have the value of t. So the value of t here for, let's say, since the variance for both group are not equal, so we're going to focus on the second row, okay? The second column, sorry, the second column. So we are looking into t distribution 7.573. So remember the formula for t distribution is x1 bar minus x bar 2 minus mu1 minus mu2 divided by the standard error, right? If the variance not equal, right, equal variance not the variance not equal, so it should be s1 squared divided by n1 plus s2 squared divided by n2. So this is what we call as the standard error of the difference, standard error of the difference, right? Which is this value is also equal to 0.56677. So we want to find this value, right? We want to prove that the standard error is equal to 0.56677, right? So then we try to input the value into the formula. So t is equal to 0.7, sorry, 7.6573, right, is equal to the mean difference x bar 1 minus x bar 2 is equal to the mean difference, right? So this is sorry, this one, so 4.2923 minus 0, because this is a two-tailed test, so mu1 minus mu2 should be equal to 0, and this is a standard error, right, we want to prove, right? So by doing the mathematical multiplication, the standard error will be 4.2923 divided by 7.573, right? So you just plug in the value into the formula. 4.2923 divided by 7.573. It should be equal to 0.56679. That's 78, right? That's 7. Where is it? 789. So 789. So 79 lah. So this is how we prove the standard error, right? Right. So state the 95% for C, state 95% confidence interval obtained from the output. So we know that the standard confidence interval here is 3.16652, and the upper confidence interval is 5.41810. So where to look? We have two different standard confidence interval. We're going to look into variance not equal, right? So we are stating for variance not equal. So test the hypothesis at 5% level of significance that the average price of season ticket spent by customer in company A is more than company B. So alternative null hypothesis is mu1 minus mu2, right? Or we can simply put mu A minus mu2. Mu A minus mu2 is equal to 0. Right? The alternative hypothesis, we can say that company A is more than company B, so mu A is minus mu B, and this is B, is more than 0. So, or otherwise, you can say that mu A equal to mu B. Alternative hypothesis, mu A is more than mu B. Right, so our alpha is 0.05, so it should be a longer space here. So test statistic, right, that's this tick, it should be t equal to 7.573, and since the variance is not equal, so we're going to take the degree of freedom is 91. Degree of freedom is 91.23. So then the next step is to create a critical region. So the critical region should be on the right hand side lah. So how to know that the region is on the right hand side? So we are looking into the alternative hypothesis. Since the alternative hypothesis is more than, so it should be on the right hand side. So this is a wait let me push rejection area. So this is acceptance area. So this one should be T 0.05 with degree of freedom 91.23. So by looking at the statistical table, 0.05 and 90 point something, right? 91 point something. So 60 plus 120 divided by 2 should be 90, right? So this one same goes to degree of value of probability 1.671 plus 1.658 divided by 2. So you will get 1.6645. So this one should be 1.6645. This is approximate the approximate value. So our decision here, since the T statistic falls, T statistic is 7 point something, falls in rejection area. So null hypothesis is rejected. So conclusion would be the average price spent by customer in company A is more than in company B. Right, so that's how we do it, the hypothesis testing. So now E, does the confidence interval in part C consistent with your answer? So part C we are 3.16653 until 5.41810. So if you're looking into the confidence interval, the confidence interval does not include 0 in the interval. So there is a difference between average price spent, right, by customer in company A and company B, right? So that's how we say it's the conclusion, and we can say the final say is yes, it is consistent with the finding, right? So that's how we answer the question. So I think we have example number 18 and 19 left. So example number 18 is quite simple. It's very straightforward question. So basically we already answered it previously, but the only difference is they ask us to use a p-value. So p-value is very simple. I already taught you in the previous in the beginning of the lecture by today, right? So if you want to find for two tail, so you don't need to divide by 2. So if you want to find for a single tail, you need to divide by 2, right? And then for example number 19, so it's quite simple and quite direct. So I think you can do it by yourself. So please do by yourself and recheck the answer with your friends. And if you stuck with the answering the question, so you can ask me by WhatsApp, right? I think for the next lecture, we will focus on the confidence interval and hypothesis testing for two population means for dependent sample. Just now we are looking into for independent sample, right? So I think that's all. Thank you very much. Assalamu alaikum.